Okay, good morning, good afternoon, or good evening, everyone, wherever you may be. Welcome to another installment of our YLP webinars. Webinars brought to you by the YLP, or the Young Leaders Program of the International Desal Association. The YLP aims to promote desalination as a career choice amongst young professionals and provide education such as these and opportunities and career advancement. So we aim to run these webinars probably on a quarterly basis. And today we have a very special guest. We are very honored to have Dr. Mike Dixon. Mike is not only an ex-member and co-chair of the IDA YLP, but he's the current secretary of the IDA Board of Directors and co-chair of their technical program. And despite his young age, Mike has a wealth of experience under his belt working throughout Australia, North America, Middle East, Caribbean, and Asia with the likes of H2O, Nano H2O. Mike currently works as the CTO for WaterNext, which is Canada's Water Technology Accelerator, as well as being a senior technical advisor for the MIT startup Sandymount Technologies. So needless to say, Mike has his finger on the pulse of a lot of interesting and developing technologies. And as some of these technologies that he will talk to you about today in his presentation, New Innovations in Desalination. Just before I hand over, I just want a little reminder to say that anytime you can ask questions just by simply adding comments to the comment stream that is available on the live stream. And I'll collect those comments and I can pose them to Mike at the end of the presentation. So if you have any questions, just please enter them as soon as you have them. On that note, I'd like to hand over to you, Mike.
Thanks very much, Nick. So today I'm going to be talking about new innovations in desalination. I got really interested in this space back when I was working on the Adelaide Desalination project. So my role at Adelaide Desal was to search the globe for the latest and greatest technologies and bring them in, sort through them, look at the very best ones and pilot them at our pilot plant facility in Adelaide. And after that, I decided that Nano H2O was clearly the best at the time. This was around 2011, 2012, and ended up going to work for those guys and getting behind making one of those great technologies as great as it could be. And after that, I decided to go out and look again. So over the last few years, I've been collecting a long list of who's innovating in the water space in general, who's innovating particularly in desalination, and who's at the top of the list and how do they compete against each other. So today I've got a list of the very best of those technologies and the ones that excite me the most as a desalter. So I'm going to click over to my slides here now. So in today's webinar, I'm going to talk about where we're at with new desalination technologies, and then I'm going to focus specifically on particular groups. So the hottest discussion right now is around brine concentration technologies, so let's deal with that one first. After that, I'll get on to low fouling technologies, whether that be for pre-treatments or for reverse osmosis or any other treatment. Then we'll talk about energy-saving pure plays in desalination. So these are technologies that are specifically focused on saving the most energy possible in desal. And then I've added a few other technologies that I think are really good right now. They're not specifically for seawater desalination, but they are for desalination practices in oil and gas. Oh, and other areas as well. So let's move into brine concentration straight away. Brine concentration over the years has seemed to have been the place where many technologies go to die, but then find a new life elsewhere. So the trend that I've seen over the years is that a new technology in desal will come out and believe that they're the next big thing in seawater desal and are going to be the breakthrough. But over the years, as they develop their technology, they learn more and more about their technology, and they think about how it can compete with reverse osmosis. They look at the numbers, and inevitably nobody's been able to break through that RO barrier to become more energy efficient or less fouling prone than a reverse osmosis unit. So these companies inevitably end up focusing on brine concentration in that space that reverse osmosis can't really work in all that efficiently. So that 100,000 TDS through 300,000 TDS seems to be the sweet spot that these brine concentration technologies get into that RO can't touch all that well. So over the years, this list of companies has been building up and building up and building up. And Tom Pankratz released a WDR article showing over 40 companies in the category. And they include a whole range of different technologies. So that includes the traditional evaporators, humidification, dehumidification, membrane distillation, forward osmosis, high pressure reverse osmosis. And there's a few others in the niche area as well, but that covers the majority of the techniques that people are using in brine concentration at the moment. So a key discussion in this area is what happened to forward osmosis. Back in 2008 through 2010, forward osmosis was slated to be the next big thing. And a lot of people, just like I said, were focusing on the seawater market. Particularly modern water came out with some very good papers at the 2011 IDA World Congress in Perth. And it seemed to be going okay. And then in the space between 2010 and 2013, that trend happened where many of them said, oh no, brine concentration is going to be a better way to go. We're not going to be able to compete with RO, so we're going to focus on those higher salinity projects. And in 2013, it was a really exciting space. In fact, we had a YLP webinar on the subject of forward osmosis, and a lot of people tuned in to listen. So people were engaged in the space and were excited about something happening. At that point, Oasis was slated as being the next big thing. And of course, over the last few months, Oasis has announced that they're closing their doors, or rather, at least they're selling on to another company because the funding has run out for them. So something's happened at Oasis that has meant that getting this brine technology, brine concentration technology into the market has been very challenging, even though that they've seen that there was a huge market in China and had focused over in China quite a lot. Additionally, in forward osmosis, HTI closed their doors. They never really recovered well from the fire that they had and struggled after that point and ended up closing. But Fluid Technologies re-emerged as the same team or a very similar team under a new name. Additionally, Statkraft in Norway that were doing forward osmosis for power generation ceased their investigations with not too much more publicly said about why they finished their investigations. Others in the space continue to power on. Peripheral, Trevi Systems, and Modern keep continuing on in the forward osmosis space. Peripheral, however, have focused their attention on food and beverage processing as they feel this is a much better market. That's not to say that they don't do some of the other applications, but they're really excited about the food and beverage processing angle of things. There's also some new contenders coming to play. Forward Osmosis, based in Toronto in Ontario, have just launched a new project and looking to pilot a new draw solution so that they can improve the process. So really, as you look at that suite of forward osmosis companies, all of them are looking at a different part of forward osmosis to differentiate. So Trevi Systems and Forward Water are looking at different draw solutions. Peripheral has an excellent module that they've differentiated, and Oasis was looking at the whole process a little bit different as well. So I think all the bases are covered there for looking at forward osmosis from absolutely every angle. And perhaps if a couple of them work together, which in some cases they do, they can really create systems that are as efficient as possible. So in my opinion, what really made the FO space challenging for some of these guys is that Ronan McGovern and his team at MIT came out with a paper showing that no other technology can compete with reverse osmosis for energy use. So those guys compared RO and FO, HDH, evaporators, the whole spread, and showed that RO is clearly the most efficient, so why go with anything else? Now, in some applications, it's not all about the energy. There are some other considerations as well, but definitely this paper opened people's eyes to see exactly what the energy use between each of the technologies is. So let's get on to humidification, dehumidification now. There's a few companies in this space as well. Saltworks and Gradient seem to be the leaders here. Saltworks emerged with a really excellent offering and focused their attention on the Albertan oil field. They did some great pilots and everybody loved it, although since then it's been slow to uptake. Part of that has been the 2015 oil price challenges that we've experienced, which Gradient also experienced down in the US oil patch as well. So Gradient have a heavily patent solution. Last I looked, they had over 40 patents in the space on their HDH technology. But due to the oil crash, they also had challenges in the space and decided to expand into other technologies and build certain businesses in other locations. So those guys are going really well right now in textiles in India, and they've also opened a membrane group as well. So while HDH might not be the leading technology for them as much anymore, they're looking to do desal in other ways and continue to innovate and become a good platform company. Additionally, there's a company out of Saskatchewan called Intercore that are quite early stage and just working on their first pilots now, but can do things in a very efficient way. And I think a company to keep tabs on and watch their progress. In the brine technology space, there are a couple of technologies I wanted to flag in particular and go into just a little bit more detail about what they do. The first of those is Heartland Water Technology. These guys are based out of Boston now, and they do things slightly differently to the other technologies. So these guys use direct contact evaporation to drive the desal process. And because of the way their technology works, it means they can work from any TDS at the low end up to a solid. So 750,000 ppm at the top end. But further to that is that they can tune their system anywhere in between as well. So it's a very flexible system that they have. The real kicker for these guys is that you can hook up their system to the back of a turbine and use the waste heat from that turbine to drive the process. So for that reason, it's a more efficient system as well. Additionally, by doing that, you get a very small uptick on the turbine as well. That very slight back pressure that it creates means the turbine becomes more efficient too. So these guys have actually been around for 10 plus years and recently got a new management team that are ex-GE, and those guys are taking it to new heights. So they've already done the 10 plus references in landfill leachate applications and have other applications as well, and just really starting out to go really well for Heartland. To highlight another technology that's slightly different to the norm is mangrove water technologies. So they're breaking the regular business model. Instead of saying in brine concentration, you have a lot of brine, we're going to concentrate it so that your disposal costs are less. These guys are saying, we're going to take your brine, we're not only going to concentrate it, but we're going to make chloralkali chemicals out of that. So, for example, they can make hydrochloric acid from their system. So not only are you getting rid of your waste, but you're creating value out of your waste as well. So it uses electrodialysis, and they have several patents in this area that enable them to use electrodialysis in a more efficient way. And they've got excellent government support from the Canadian government of $4 million. So they're going really well so far. They're looking for piloting locations and the exact product market fit for them in the right application. So they're looking at things like the oil sands, they're looking at things like semiconductor, and finding just the right sweet spot to get into to really maximize the value that they deliver. So an exciting company, Mangrove Water Technologies. The last company in the brine concentration space that I wanted to mention is Osmoflow. So people know Osmoflow well, they've been around a long time. Over the last few years, they've developed a new product called the Osmoflow Brine Squeezer, or OBS. So these guys really listened to the McGovern story and thought, well, if we can push the boundaries of reverse osmosis, then we're going to do the desalting as efficiently as possible. So these guys use high pressure reverse osmosis and can get to over 1500 psi. So here, basically, the membranes become much more of a throwaway item and less of the case of, hey, we want the membranes to last for 5 years, because they're working with a different value proposition. They're not working with straight salt water that we're making drinking water out of. They're working with a material that we want to concentrate and get rid of as quickly as possible. So going through membranes a little bit faster than usual is okay in this scenario. So these guys have been able to get from the 50,000 to 175,000 ppm levels. Now, 175,000 ppm might not be the be-all and end-all, but the OBS is something that you would put in the front of another brine concentration technology. If you need to go all the way to solid, you would use something like a crystallizer or something like one of the other technologies. But by putting this in front, it takes the brunt of the work and therefore greatly reduces the amount of energy required in the full system. Okay, so let's move on to low fouling technologies. There's quite a few in this space. Akvola Technologies out of Germany has a really interesting technology to cut the footprint of the pre-treatment and keep fouling as low as possible. So these guys have dissolved air flotation plus ultrafiltration in a single module using ceramic ultrafiltration modules. So by doing this, it dramatically reduces the footprint, and therefore you're spending much, much less money on preparing your site. Another one is called Swirltex. These guys create a vortex inside a tubular ultrafiltration membrane. And in addition to that, they inject gas. So by creating that vortex, it means any solids in the material are drawn to the center of the vortex and don't touch the outside of the membrane. So that means that you can go to much, much higher fluxes than a regular UF membrane. In some cases, they've seen up to 5 times the flux that you would see on a regular tubular UF membrane in the applications that they're working in. So right now they're working in wastewater lagoons, but the application of this technology is great. And I hope over time that they'll see other areas they can get into and really expand the areas they're working in. Another is Polycera. Polycera is riding on the back of Eric Hoch's success out of Nano H2O and doing very, very well. So their ceramic polymeric ultrafiltration hybrid can get 10x lower costs. So what's really good about it is that it's highly oleophobic, and hence that makes it really excellent to use in oil and gas. So you can see in the diagram below the text here is that the surface repels oil very, very well. So this means that the oil is no longer fouling the membrane, and therefore you can get higher fluxes, but you can also have longer periods between backwashes, longer periods between cleans, and therefore a much, much more efficient system. So this really solves a problem in ceramic membranes. In places where they've been tried in the oil patch before, the trials have gone really badly due to fouling, and this helps solve that fouling issue. So the surface is neither a polymer nor a metal oxide, it's a true hybrid, so a very, very interesting technology indeed. So we've got a few membrane companies on the docket today as well. So these guys are really early stage and still developing their membranes. But as we found at NanoH2O, this can be a very long lead time just to get to the point of selling even pilots. So Enfiro has been working on some NF and RO membranes using self-assembling block polymers. So by aligning the polymers, it means there's a straight flow of water, you can see in the diagram on the right there, and thus leading to higher permeability. So because you don't have that tortuous pathway that RO has, means you can get these much, much higher fluxes. And Enfiro are claiming that they want to get up to 3 times increase in permeability compared to regular reverse osmosis. A really big win with these guys is that they're not damaged by chlorine. So that's really going to help the biofouling problem as well. In addition, that they're cost competitive with existing materials for roll-to-roll manufacturing, which is really important compared to something like graphene that we're going to get into in a moment. Mattershift is another company as well that are looking at new membrane surfaces. These guys are looking at radial aligned carbon nanotubes. So by doing this, you create programmable gateways, only allowing certain substances through. So that really lends itself to desalination, because then you can say, let's tune these gateways to let water through, but not let salt through. And therefore, you can get a really efficient membrane. So these guys are also in the early stages of development as well, but we stay tuned to what they're doing. So a lot of people have been talking about graphene over the years because it's been slated to increase flux by 10x, or even better than that. So the problem with graphene is that it's been very, very slow to develop. I think 5 years ago, it was slated as 5 years' time. And I don't think that the progress has been made to really get to this to the point of being a roll-to-roll or something that can be used at the larger scale. So Lockheed Martin were really pushing the envelope and were owning the space a few years back and developing things well. Although we haven't heard from Lockheed Martin in at least a couple of years, and it's unclear as to where they're taking this exactly. The other 2 universities that were working on the problem, MIT and University of Manchester, are continuing in the space and making some progress. So I had a discussion with one of the Manchester teams at the Sao Paulo IDA event, and these guys have now looked at layering graphene inside a epoxy sandwich. So basically they would go graphene surface, epoxy, graphene surface, epoxy, like that, and then make a large block and then shave the top layer off the block, and that becomes the membrane. So the problem with that is that you then have a very, very high flux zone and a dead spot where no flow goes through the epoxy. So there's then a trade-off between the high flux that you win of the graphene and the lost area of the epoxy. In addition to that, rolling that into a large membrane becomes challenging, and therefore a new paradigm is needed to make that work. So those guys are developing that, and it's exciting to see where that's going to go. Another solution is multi-layering sheets. Because graphene is so thin, it's possible to stack these on top of each other and get the same thickness as an RO membrane. And this takes care of the defect control that is really the Achilles heel of graphene. So we'll see where that goes as well. Over the last few years, another new exciting space has come out, metal organic frameworks. And perhaps this is a better avenue than graphene, although it's early days in that space, and we're all ears to see how that goes. Okay, so let's move on to low energy pure plays. So one company that's exciting me right now is Penny Energy. So these guys have a technology called adaptive desalination technology, and it's an intelligent seawater RO plant process that adapts to take advantage of the variable demand of fresh water and variable price of electricity. So the process is fairly under wraps at the moment, but it requires a small amount of capital upgrade and then some proprietary algorithms to control intelligently what's going on the plant and balancing flows between certain areas of the plant. So research has been going on at Victoria University in British Columbia on this for quite some time, and they claim that the minimum energy consumption of their system is greatly improved compared to standard at comparable salinities. So these guys are really getting into the space now, looking at some pilots, and I really hope something goes well here, because I think there's good potential here after it's been proven in a first and second pilot. Another way of looking at things is changing the flow-through nature of RO and focusing on batch and semi-batch processes to greatly enhance the energy. So this really requires a serious mindset change, as does Penny Energy as well, in that if we do things slightly differently and we construct and design our plants slightly differently, then we can save a lot of energy. But this requires quite a lot of proving period to get to the point of the industry being comfortable with what's going on the research side. So batch and semi-batch, and by semi-batch I mean things like Desalination technology, could save up to 25% of energy uses. It can also harness some of the high permeability membranes like graphene that we talked about previously, and provide a better process than that continuous process for energy savings. So on batch RO, Rick Stover was quoted to say that for these reasons and more, batch and semi-batch processes are the future of RO. So there's quite a few people who are quite respected in the industry that are looking at batch RO to say, hey, this really could be the latest and greatest in desal technology. So there's two more potential technologies that I wanted to talk to you about today. One is mole air. So mole air is a nanobubble generator. So this can be used to greatly enhance the efficiencies of a lot of different technologies. Most importantly for desal is in dissolved air flotation. So these guys inserted their system in place of a DAF pump and found it much, much more efficient than a DAF pump for creating the bubbles in a DAF system. So what mole air does really well is inject oxygen into systems to change the parameters within them. So for example, you could install this in an effluent lagoon or a lake and cut down algae growth. Or they've also been using it in food production, which is really interesting, and increasing yields of things like leafy green vegetable growing. So it's an exciting space. It's not just exciting for helping desal technologies, but a lot of other technologies as well. And it just happens to be the ex-Nano H2O team. So in terms of startups, those guys know what they're doing. The final technology today is ZDIA process solutions. So these guys aren't really focused on desalination per se, but in treatment systems in oil and gas. So within an oil and gas system, you may have a downstream desalination technology of a walnut shell filter. So this is helping the system as a whole. So these guys have modified walnut shell media filters. And in oil and gas, walnut shells are used to remove oil in water and any hydrocarbons in the water so that the water can be reused and other applications as well. The really good thing that I like about this technology is you remove your walnut shell filters and insert these modified filters. So it's a very easy, an easy technology to pilot for companies. It's not a case of installing a whole heap of new steel in the ground. It's simply take out your old media, put in the new media, and if you like it, keep it, and we'll keep servicing the technology. So if you look at the graph below, it shows oil in water concentrations, and you can see the blue and orange regular, or blue is oil in water into the system, orange is a regular walnut shell filter, and the green at 0 is the modified ZDIA material. So it performs very, very well. Okay, so that brings me to the end of the presentation today. I'm going to go through a very quick synopsis now of my feelings for new technology in the desalination space. So first and foremost is we don't need any more forward osmosis companies. As I talked about, the companies that exist now are looking at all sides of the forward osmosis story. They're looking at the draw solution. They're looking at new towers for recovering the solution. They're looking at modules. So I think we've got all of our bases covered as an industry there. A point I wanted to make about brine concentration companies is that there's a lot of companies in this space. So if you're a brine concentration technology and you're trying to get into the space, you better be 10 times better than everybody else. Now, 10x is something that gets thrown around Silicon Valley as, hey, you better be 10x better than everybody else. Realistically, in desal, we're working against the realism of thermodynamics, and you might only be able to get 10% or 20% better, but you better be 20% better than the best brine concentration technology, not 20% better than evaporators and crystallizers. And my last point is that energy-saving pure plays are really exciting. And I think anytime someone comes out with this, it gains attention. But it's most likely going to require a mindset change on our behalf as desalters on the way that we do things. And this is really similar to the pressure exchanger. Previously, the way that we did things piping-wise on an RO system was very different to the way that we do systems with a pressure exchanger now, but we had to change our mindset to allow for that. So that's all I have to talk about today, but I'm very open to going through some questions with everybody.
Thanks, Mike. That was really interesting and really informative. I think you gave a really great overview of all these different technologies in a very short space of time. So yeah, if anyone has any questions, please write them into our live stream on our YouTube page, and I'll be able to pose them to Mike. And while I'm waiting for your questions, I'll fire off a few of my own. I want to start with maybe some questions regarding the brine squeezers. Do you think that there's a market for, say, mineral recovery from brine squeezing or zero liquid discharge applications? I guess that's probably where Heartland's coming in, is it? Is that right?
I don't think Heartland do mineral recovery per se. I think the closest to that is the mangrove system, where they create chloralkali chemicals rather than the minerals. But actually, seeing as you mentioned that, there's a Canadian company called E3 Metals, and they're taking oil and gas wastewaters and creating lithium from that. So in oil and gas wastewaters, just taking the lithium out isn't cost effective. But if you have a technology to concentrate those minerals, then reclaiming the lithium then becomes a much more practical scenario. So over the years, people have talked about this a lot. In fact, you'll find TED Talks on the concept of reclaiming minerals from seawater, but I don't think seawater is the right place to do it. Oil and gas wastewaters and the brine concentration field is definitely somewhere that it can be much more practical. So it would be exciting to see something in that space and see the economics of doing that.
Okay, thank you. What about for other brine squeezes? Is there some sort of like economic cutoff in terms of how much extra, let's say, water we can get out of from traditional RO? How much extra recovery we can get, for example?
In terms of cutoffs, so your RO is going to cut off at around the regular RO at up to 1200 psi is going to cut off in the range of 60,000 to 80,000 ppm, depending on the salts that you have in solution. In terms of other cutoffs, it seems that in the 300 to 350,000 ppm, most of the brine technologies are getting to that point. So let's take humidification, dehumidification, and forward osmosis seem to be somewhere in that range. Now, please don't call me after this talk and say, like, this particular technology can go to 351. Like, that's a rough idea of things. The direct contact, like Heartland, can go up to 750, as well as Saltworks can go to the much higher as well, because they have their salt maker system that not only concentrates but crystallizes at the same time. In terms of economics, the cutoffs are all relative to the evaporator crystallizer process, and also in relation to trucking distances to disposal wells and the cost of disposal at that particular location. So if you're trucking 300 kilometers with your 30 meters cubed in the truck, that's probably much less economic than concentrating on site and only transporting 1/10 of the amount of trucks.
Lost your mic. Fair enough. I think we lost your mic briefly at the end there, Mike.
Oh, I'm sorry.
Yeah, so that's better. You're back.
Good.
All right, we have a question from Quantum Way. He first notes, great talk, Mike. But he asks, can you talk a bit about closed circuit RO or semi-batch RO and say how that's doing?
Very good. And I think probably Quantum is a better person to talk to this than me, because Quantum works directly in batch RO with MIT, and shout out to Quantum as one of the YLPs. Anyhow, so closed circuit desalination by Desalitech was going really well in the brackish water space over the years, but those guys have turned their attention to industrial waters rather than brackish municipal. They had also done some seawater systems as well, but again, it turned their attention away too. So my gut feeling for that is that it was a commercial thing, and that it's much easier to move a new technology in industry rather than moving in municipal. On the technical side, Quantum, I think you're a much better person for talking about it than me. I know that you've made great strides into batch RO and can show like 25–30% energy savings. So maybe the next YLP webinar can be from Quantum.
Let's hook him up. I like the idea of that. You mentioned also the fact that ceramic membranes had issues with fouling in oil fields. Can you maybe elaborate on that a little bit?
Oh, yeah, there was a trial here in Alberta that used ceramic membranes, and the real problem there was they didn't set up their cleaning from the get-go as good as it should have been. So it was set to steam clean, the steam wasn't delivered in the right way, and hence it fouled terribly. So the problem was all fixed and it fouls less now. But, excuse me, the real problem with oil systems is that the feed water quality is quite variable. So it'll move along quite stable, and all of a sudden you'll have an excursion in the oil and water. And those excursions are really bad for ceramic membranes. So it's basically taking a whole heap of oil and sticking it to the surface of the membrane. So hence it fouls really badly and is very difficult to recover after that. So that's one of the benefits of the Water Planet system, is that they're using their new IntelliFlux technology that controls the flux when one of these excursions comes through. So it detects an excursion, it lowers the flux, and hence the fouling is much less. And then after the excursion has passed, the flux is allowed to return.
Super. Thanks, Mike. Quickly on graphene membranes. So obviously there's talk about increasing, the ability for them to increase permeability on traditional polymeric membranes. But surely the limiting factor in RO is the osmotic pressure.
Absolutely.
Are we not going to get much gains of decreasing transmembrane pressure across RO membranes from a desalination system? So what are they offering to the market? I mean, I know they've still got a lot of work to bring the cost down, but provided they bring the cost down, where would they have their value?
Sure. So, flux and rejection is intimately linked. If you go up in flux, then rejection goes down, and vice versa. So, and this is one of the problems that we had at NanoH2O, is that we came onto the market and said, we can get 20% more flux. But it wasn't in absolutely all of the cases. It was a certain few areas where the salinity allowed us to get to those higher fluxes without sacrificing the permeate quality. So if you can say in any system the permeate quality can be much worse, then you're going to save energy. So in graphene, it remains to be seen as to what permeate quality is going to work. And personally, I would love to see a research paper on exactly how that permeate quality can stay down at the same time as keeping the flux really, really high. I haven't personally seen it. Maybe something's come out of Manchester or MIT looking at that. If there's something out there, I would love someone to send it to me. Otherwise, I would love to see one of those universities get into that study and really explore that space and see how it's going to work in future with graphene.
Super, thank you. Another question regarding matter shift. You talk about this technology being tunable for salts and other compounds. To what extent is it tunable? Does it mean that we can select specifically which salts go through? For example, can we say we want magnesium ions to pass through or be rejected, or vice versa?
Absolutely, yeah. Those guys are looking at tuning their surfaces not only for sodium and chloride, but a whole host of other things. So they're not just talking about desal, they're also talking about lots of other applications. So it's incredibly tunable. It all comes down to the chemistry that you install at the end of the carbon nanotube. So that in that, it creates the tunable nature of the carbon nanotubes.
Okay, very interesting. Recently, there was a publication, I don't know whether you'd come across it, and a patent application by Professor Yu at the University of Texas, who's developed a new hydrogel that, together with sunlight, is used for essentially some sort of solar desalination. Have you come across it?
I haven't come across that one in particular. Solar solar is really interesting. So there was an Australian company that came out of National Centre of Excellence in Desalination that looked at using solar energy to desalt water. So the company was called F Cubed, and they essentially set up panels very similar to solar panels, and thus you would need to have a field of them to create enough water to use for a village or a small town. So I think in those situations right now, they work really well for small communities or one or two people, but they need to be developed further to work at much higher capacities. Now, I haven't read that paper from University of Texas. Maybe they've got into solving some of that, the area that they need to do it problem.
Well, that was essentially what my question was going to be, whether it was more suited for smaller remote scale or larger scale, but I'm sure we can talk about that outside. All right, maybe just to wrap up, what do you think? You've brought all these interesting, exciting technologies and presented them fantastically. What for you do you think is the number one, the most exciting technology? Number two, that will probably see the fastest commercialization. That's basically ready to hit the market. Or maybe three, what will have potentially the biggest impact to desalination or water treatment as we know it.
Okay, so on number three, if graphene works itself out, then that can have a huge impact. But the likelihood of it working out right now is very unclear. So it's exciting and it can make a huge impact, but I think we're not there yet. And I think it's very clear to distinguish not yet rather than it's not going to happen. The most exciting for me are the low energy technologies. So something very similar to the Pani energy scenario, I find really exciting. Because I think any saving that we can make energy-wise in desalination is really, really important, not just for our costs and resources, but for the reputation of our industry as well. And I think your third question is, which do I think will be the most successful, fastest? I think the two technologies I mentioned at the end, Molaire and Zedia, but not because of their technologies, but because of the management teams behind them. So in commercialization, your technology matters for about 1% of the journey. 99% of the journey is the sweat put in by the management team, the sales team, marketing team, and everybody putting the whole package together. So Molaire, those guys know what they're doing, and hence I think that'll move really quickly. They've already shown it's moving quickly. And the Zedia guys, while a little bit less experienced than the Nano H2O guys, really do have good experience in the industry, being ex-Pentair. They have an excellent value proposition. They know what they're doing, and I think that one's going to move really fast in oil and gas as well.
Okay, that's great. Mike, that was fantastic. I have to say, I found that personally extremely interesting and entertaining. I'm pretty sure that all of our other listeners did as well. Obviously, it's available for those who are online now. It's going to be available on YouTube for rewatching later if there's any of the details that you missed. And I mean, everyone knows Mike and myself. We are very contactable anytime. So if you have any questions for Mike, I'm sure you can find him on LinkedIn. Otherwise, shoot some questions through to me, and I'm happy to pass them on to Mike as well. So yeah, thanks for your time. Thanks for everyone who's tuned in all around the globe, and we'll catch you for the next installment of our webinars.
Thanks, everyone.